My name is Brooklyn Lyons, and this is my PowerPoint on how we can harness heat energy to power the world. Heat energy. It is the flow of energy from a warmer object to a cooler object. All matter just happens to contain heat energy, such as volcanoes, ice, and even our bodies. Heat energy is the result of the movement of atoms, and it can be transferred from one object to another. This transfer of flow is due to the difference in temperature between two objects. There are three ways to transfer heat energy, which are convection, conduction, and radiation. Radiation is the transfer of heat energy through gases and liquids. An example of this transfer would be as air heats up, it rises. Cooler air will move in below the warmer air, and it will heat up and rise as well. As the air cools, it becomes denser and it falls. This heat energy flow creates a convection current. Conduction is the transfer of heat energy through solids. An example of this would be a car being turned on, and as the car heats up, the engine becomes hot. And the hood becomes warm as heat is conducted from the engine to the hood. Radiation is the transfer of heat energy by infrared waves. An example of this would be sitting by a fire and feeling the heat coming off of it. Solar energy. Solar energy is the light and heat that comes from the sun, and it can be harnessed in different ways, which are photovoltaic cells, solar thermal energy, and passive solar heating. Photovoltaic cells convert sunlight into electricity. This happens by sunlight hitting the surface of the cell, and then a semiconductor converts the light into electricity. An example of a photovoltaic cell would be a solar panel. Solar panels are actually made up of many photovoltaic cells. Solar thermal energy is the second way that solar energy can be harnessed. This is heat from the sun is used to make hot water steam. And this process happens by a mirror or reflector concentrating the sun's rays to heat a specific kind of liquid. The heat makes the liquid boil water to create steam. The steam spins a turbine connected to a generator. This generates the electricity. An example of this would be solar panels that harness thermal energy can be used for heating water in homes, buildings, pools, and etc. And the last way is passive solar heating. This is really just as simple as letting the sun shine through a window to heat the inside of a building. And as stated previously, example would be sunlight streaming through a window on a cool day, and your house instantly feels warmer. The best way for this to happen is through a large window on the south side of a building where there's no shadows and no shade. As reported in 2015, the total water energy usage, which is coal, oil, hydroelectric, nuclear, and renewable energy, was 13,000 million ton oil equivalent, which is equal to 17.3 million terawatts. Now, if we were to cover an area on Earth that was 335 kilometers by 335 kilometers with solar panels, this would provide us with 17.4 million terawatt usage. This equals an area of 43,000 square miles. And the Sahara Desert is 3.6 million square miles. and is prime for solar power. This could be equal to more than 12 hours of solar energy used a day. So this means that the Sahara Desert is 1.2% sufficient to cover all energy needs of the world in solar energy. With this, no other energy source could even compete with this. Of course, the cost of this would be $5 trillion, but it would be 1/4 cost of the U.S. national debt, and it's equal to 10% of the world debt in 1 year GDP. So this would make it a smaller cost compared to other spending. And it can be said that in 20 to 30 years, solar power will replace any other type of energy. Geothermal energy is heat from the earth and it's clean and sustainable. Geothermal energy is generated within the earth and can be harnessed in many ways, which would be geothermal heat pumps, geothermal hot water, and geothermal hot dry rocks. However, geothermal energy is not 100% clean, but it is 100% renewable because greenhouse gases still emit some stuff into the air, but it's less than burning fossil fuel. Hot springs are considered to be an example of geothermal hot water because they can be found underground. So they can be pumped directly into application for hot water, or they can be used to heat buildings, grow greenhouse plants, fish farming, or pasteurizing. Hot dry rocks are another way to harness geothermal energy. It's also used in this way. It's used to generate electricity. Cracks or pores in the rocks release the geothermal energy, and that's where it's captured. But however, if the rate of geothermal energy release isn't sufficient enough, high pressure cold water is pumped into the rock. Then the water captures the heat and is forced out of the ground in the form of hot water. The discovery of fire was mankind's most successful attempt to harness energy. How is this? Fire created portable warmth, it created light, protection, and it was a new way of preparing food. Electricity is known to be a high-grade energy because it can be converted into other forms of energy, and it can be used and stored without significant loss. Thermal energy is low grade because the attempt to transfer heat back into other forms of energy tends to be costly and inefficient. A silicon device has been created by Sandia National Laboratories. They call it a rectenna, which is a rectifying antenna. It's made of silicon dioxide, aluminum, and glass. It is all crammed into a tiny 1/8 by 1/8 inch space. It is able to generate electricity from waste heat. Waste heat can be used to generate electricity by the use of the thermal galvanic effect. The thermal galvanic effect is the dependence of electrical potential on temperature. In one cycle, electrochemical cells are charged at a certain temperature, then discharged at a different temperature with higher cell voltage. This converts the heat into electricity. Heat can also be used to power computers. However, the biggest problem with computers is keeping them cool so that they won't shut down or they won't overheat. So, two university engineers from the University of Nebraska-Lincoln are embracing heat as an alternative energy source by creating a thermal computer. And the development of this thermal computer came after the questions of how can we keep this computer cool. After creating this thermal computer, it is said to have worked in 1300 degrees Fahrenheit, and this computer could help limit the amount of energy being wasted. He can also be used to power electronic devices. A thermoelectric generator is a device that converts a temperature difference into a voltage and it manages the flow of electric current around a circuit. Thermoelectric generators are also a key power source for space instruments such as the Mars rover and the Voyager 2. The Pharos project is known as a way to help scientists, researchers, and engineers to identify problematic chemicals and collaborate to find safer alternatives. The Seebeck effect is known as the temperature difference that creates an electrical voltage at a junction between two different materials. This voltage can be used to drive a device or can be used to charge a battery. And here are my references that I use to find all my information.